Hey, this is Step Amit. Welcome to my Exorcism.io series. In this video, I'll be working through the simple cipher exercise from the Exorcism.io Ruby track. Our task here is to implement a simple shift cipher, like a Caesar cipher, but with a more secure substitution. Oh, and a more secure substitution cipher. So one of these Caesar-style shift ciphers, you simply move each letter in your plain text, you shifted a certain number of characters in the alphabet, and that gives you your cipher text. So what we're going to do here is also introduce a key, the concept of a key. So depending where you are in the key, the letter in the key, they will all be lowercase letters. The letter will tell you what the offset is. So an A has an offset of 0 because A is also the first letter of the alphabet, but D would have an offset of 4, or I guess A, B, C, D, 0, 1, 2, 3, an offset of 3, whatever the distance is between this letter and this letter. And so, whatever position your plain text is in, you'll simply offset that letter. You'll shift it by the distance between the letter in the key and the alphabet. Okay. Then we also want to generate a default key that is a random key of at least 128 characters in length. All right. That, I think, is it. Let's go ahead and copy this and dive right in. Start a new TMX session. Open up the tests, and I'll real quickly open up my testing pane. I copied in that rake file. The rake file allows me to run my test by simply by running rake at the command line. And in Vim, I have a mapping set up that when I hit F8, is what I'm using at the moment. It will execute the test. It'll open up the bottom pane. It'll execute the tests. For some reason, I always have to run it twice. The first time, it swallows the R for some reason. That won't happen again. It'll open up the bottom pane, run rake, which will execute the tests. If there's an error, it'll stay open like this. If there's not an error, it will close. But you can already see the first error here. The problem is I deleted the simple cipher.rb file, so I'll create that in a second. But first I want to look and see what I've got going on here in the test. So there's a file, simple_cipher.rb, that I need to create, and it will define a class called cipher that we will initialize, and cipher will respond to key, and it will return whatever the key is. It will have an encode method that will take plain text and return the cipher text, and it will have a decode. All right, so let's see. All the tests, I believe, are skipped at the moment, but there's some other things that are happening here. These setups, I think, oh no, here's a test that is not decoded. So this might be the first thing. But again, we already saw that the first error is I deleted that file. So let's just create it here. And I'll swap my test running panes because I like to have my class on the left. And now the error is uninitialized constant cipher. So that's what we need to do, class cipher. The next error, I think, should be from that test on line 9 here, in that we are returning, so that there is no key. There's no key. I didn't save my file. Okay, there we go. Oh, so the error is also not what I expected. Wrong number of arguments. That's because usually we're going to pass in a key, and the initialize method does not accept a key. So I need to go ahead and define that. First, I'll define an adder reader for the key. And then I will take a key as an argument in initialize, but I need to default that to, for now, I'll just make it a string of A's. This needs to be we'll make this a randomly generated string in a few minutes here. But let's see, key is equal to key. Okay, so this first test, key is a series of lowercase letters, and that matches. All right, so for the first test here, we're gonna it's let's see, test, cipher, and code. If the plain text is all A's, then I guess this is 10. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 letters. Then the cipher key. Oh, okay. Then when we encode that, because here, let me just read this. Here we take advantage of the fact that plain text of AAA doesn't output the key. This is a critical problem with shift ciphers, so that characters will always output the key verbatim. Okay, yeah. So if we just give it A's, if we put in A's, then it's going to tell us what the key is. So that's exactly what this is going to do. We're going to pass 10 A's, and it's going to return the first 10 characters of the cipher. So let's just run this. I think this will work. Undefined method encode. Well, oh yeah, of course it won't work. I haven't defined encode. Def encode, plain text. And I'm just going to return the key for now. I'm just going to return plain text. How about that? Let's try that. Okay. And then decode. This will fail because I haven't defined decode. But I'm going to do the exact same thing. That'll be enough to get started. It's going to accept ciphertext and return ciphertext. All right, test the cipher is reversible. So plain text, I think this will work because we're not actually changing the text we've been given. So we're just going to pass it around, that A, B, C, D, E, F, G, H, I, J. Incorrect key ciphertext. Test cipher with a caps key. So this test will fail because we're not raising an argument error. We're not doing any kind of validation on our input. So I want to do that now. So what I need to do here is raise an argument error unless key match. And I only want it to contain lowercase letters. So we need to start at the beginning and give it a range of A to Z. And we need a plus sign to indicate one or more. There has to be at least one, but there can be more. And then the $sign to indicate the end. So that means this will only contain, the key must only contain lowercase letters. I think this will make that pass. And so numeric key should also fail, or should also raise an argument error. And then an empty string should also raise an argument error. Okay, cool. Okay, let's try another test here. Test that the cipher key is as submitted. So this just says that we're going to give back what we were given for the key, which this will pass because we're using an adder reader that it's just going to return the value of that instance variable. Test cipher encode. This is going to fail, and it's going to force us to actually implement this. So the plain text is all A's. The cipher text is now A, B, C, D, E, F, G, H, I, J. So because plain text is all A's, we should get back. Oh, wait. plain text is all A's. Oh, the key has been set here on line 60 to A, B, C, D, E, F, G, H, I, J. So since the plain text is all A's, we should get the key back as the ciphertext. And we won't because we're returning plain text. So we now need to actually do some work here. All right, in order to do this, what I need to do, I need to transform each letter of my plain text. I need to shift it based on the key that I have. So because I have, I want my ciphertext to be the same length, right? Because I'm taking each letter and transforming it. That tells me right away that I need to get the chars from, take my letters of my plain text and turn it into an array of characters, of individual letters. So I can do that with chars. And then I want to map over those because I want to transform that array into a new array based on the transformation that happens because of the key. But it's not enough just to map it, because I also need to know where I am in my string. So I need to map with index. And that will give me both my character or letter, and it will give me an index, the position within the array of characters, within the array of letters. And I need to do some sort of transformation here. I need to do some kind of shift. I need to shift up. Well, I'm just pretending this exists. Shift up my letter and my I, my index. So I'm pretending I have a method here called shift up that's going to take my letter and move it up based on an index, which will tell me where I am in this key. And then somehow from that, I have to derive a distance. All right, let me start building out. Oh, and then I'm going to need to join that result back together because I've got an array and I want it to be a string again. So I'm going to create a private method here. And I've already gone longer than I'm comfortable usually going without a passing test, but I've really got to build out some initial implementation of this transformation. So I'm just going to do it like this. So shift up takes a letter and it takes an index. And so I need to get a distance. I need to get a distance here. Because I want to do something like this. I want to take my letter and get the ordinal of it, which is just the number that represents that character. So A, I'll just do it in IRB. If I have the letter A and I ask for that as an integer, that's 97. That's the offset from the beginning of all the characters, the integers representing those characters. So lowercase a begins at 97. So if I want to go, so if my key is D, then I want to know the distance between those things, right? So 100 minus 97 is 3. If I take A, let's say that's my first letter, and I want to shift it up, I add 3 to it. That will give me 100, which will give me back D. If my letter is, let's say, C, and I add 3 to it, that's going to give me a new letter, so 102. 102, I can turn that back by calling, CHR. And that will give me the letter F. So see, because my key value was D, and my input letter, my plain text letter was C, I have to shift it 3 letters up, which will give me an F as my ciphertext. That's what I need to do here. So I need to take my ord, my letter.ord, and I need to add the shift distance, let's call it, for the index. And then I need to take this whole thing and I need to get the character back for that. This is, of course, still not going to work because shift distance doesn't exist. So let me start creating that. I'm real uncomfortable about how far I'm going here. I haven't seen green in a while. I feel like there's going to be some failures to work through once I think I have this worked out, but we'll see. Maybe I'll just nail it. So shift distance. So based on the index. So what I need to do here is get my key, and I need the element at index. And then I need to get the ordinal for that. And I need to subtract 97 because that is A, right? That's the beginning. So this is the distance. So if I take my letter, my input letter, convert it to a number, to an integer, I add the shift distance for that index and turn that back into a char. Oh my gosh, is this going to work? Oh my gosh, that worked? That actually worked. All right, so that encode works. Wow, I kind of didn't believe that would work. All right, so we're gonna have to do the opposite for decode. So let's get in here, and what I'm gonna do is just copy this. I'm gonna paste it, but instead of shifting up, we need to shift down. So shift down is gonna look a lot like shift up. Except we're going to subtract our shift distance from the letter.ord. Okay, we don't have, sorry, I copied pasted. We don't have plain text here. We have ciphertext. All right, cool. Let's keep going. I think I'm gonna have some good refactoring here to do at the end. I've got lots of duplication that I think I can clean up. Although it's a little tangled, we'll see. Ciphertext is reversible. Yeah, I don't know why it wouldn't be. Test double shift encode. Okay. Wait a second. Oh. All right. What happened there is by doing a double shift encode, we ran off the end of our lowercase alphabet. We need to make sure that the results of this math here are letter.ord plus or minus shift distance is within the lowercase alphabet. Because what you do when you're shifting here, so for instance, if we here's the example. E, if we're shifting it to the left, becomes B. D becomes A. Well, what happens with C? Because C will go before the beginning of the alphabet, so it'll be before A. Well, you rotate around. You roll to the end of the alphabet. So we need to roll to the beginning or the end of the alphabet here. So how do we do that? It's going to involve modulus math here somehow. To get this letter. So I've got this number, And I think I need to get it back to, I need to reorient my lowercase alphabet back to the beginning to start at 0. So instead of 97, so in order to do that, I want to simply subtract 97 to make it 0 base. So if I've got an A, it's going to be 0. It's going to be that. So 97 will become 0. But then, because I might be below or above 0, I need to modulo 97. No. 26, right? The number of characters in the English alphabet. And then I need to add back that alphabet offset. So let's see, how many of these guys do I need to add here at the beginning? 1, 2. Is this right? Man, oh man. All right, I need to do the same thing down here. I'm really going to want to clean this up. This is really tangly. This would be impossible to come in and detangle without having context. We're going to want to name some of these things too. It's not immediately clear what these numbers mean if you don't just know. Let's just see if this works. Oh, yes. All right, so again, let me explain what I did. The shift distance is the distance between the letter in the key at this index and the letter A. And we want to subtract that or add that, depending on whether we're encrypting or decrypting, to the letter that we're encrypting or decrypting. The problem is just doing that bare math might put us outside the bounds of the alphabet. So we want to reset. We want to roll around to the beginning or roll around to the end of the alphabet, depending on which way we rolled off. And so what we want to do is get our alphabet, get our numbers back to a zero based, so that we can do modulo math to come up with a number within that range of 0 to 26. So we subtract 97, which is the offset. That's where A is, the ordinal is actually 97. So I'm going to set it to 0. And then I'm going to do modulo 26 to bring that number within, to make sure that it's within 0 to 26, because the remainder will be that number or wherever it fits within that. And then add that offset back on so that we shift that lowercase alphabet back up to where it needs to be, to actually be within the range of the lowercase letters. And then .chr will of course turn that back into the actual letter. So that worked. So let's see if so test cipher encode wrap. I believe this is going to work. So let's see. Test cipher encode. Think it'll work. I believe this is probably all that I need to do. Cipher decode. This should work. Make sure that it's reversible. And that's the last of the tests. But one thing I noticed here is that there's no test ensuring that we generate a random key. So I want to do that real quick. Let me call generate key, which of course doesn't exist. But let's show you how I would implement this. Generate key. And I want, it has to be, they want it to be at least 100 characters. I'm going to make it 128. And so I'm going to create an array that is 128 characters in length. And I'm going to map this. And what I want to do is I want a random letter. So let me pretend this exists. I'm going to write the code that I wish I had. Random letter, which will be, so I need a random number up to 26. And then I'm going to shift that to be within the range of the alphabet characters, the lowercase alphabet. And then I need to convert that to a CHR. And so that should generate a key. Oh, okay. What undefined method match for, I need to join this together to be a string. Okay, so now what's the error? What's the problem here? I have two errors. One, failure. Undefined method ORed for nil class. I didn't generate an array that was 128 characters long. I generated let me show you what I did. My error here, I meant to create a new array new, with 128 elements in it. That would be this long. But what I actually did was, what I ended up doing was I used a convenience method on kernel for making an array out of whatever input you give it. So array open parentheses 128 gave me a 1-element array with the integer 128, and then I simply replaced that with a random letter. So that's what I did. This is part of the problem of I for the last 3.5 months I've been using Java on the job every day, and no Ruby professionally since December, and so my brain gets stuck between them. So array new 128 map, everybody should be happy now. Yay. Okay, cool. I'm going to close my tests, and then I'm going to start refactoring this. So let's see. The first thing that I see is I've got all these magic numbers everywhere. So I'm just going to start extracting them to constants. So key length. Nope. I mean, that's fine. Nothing should break because of it, but I want it to be 128. 26 is, of course, the alphabet length. Um, 97 is the alphabet offset. All right, let me go ahead and replace these. So 97 should become alphabet offset. And then 26 should become alphabet length. Okay. That should all be happy now. All right. So with all this duplication here, I see the only difference between encode and decode is, other than the name of the parameter I've been given, is what method gets called inside here, shift up or shift down. So what I think I want to do, and even the parameters that you pass to shift up or shift down are the same. So what I think I want to do is I want to create a method that combines both of those, and I'm going to call it process. And then I'm going to give it here ciphertext, and I'm going to give it the name of the method I want to call, shift down. And so let me first go ahead and just define it right here because I've got it. Process to take input and that should work. No. Wrong number of arguments given. It takes input and it takes method. Let's call it not method. Let's call it shifter. Shifter. And of course it works because we're hard coding it to shift down, but it's not going to work if we call process plain text with shift up. That's going to break every encode because right now it's hard coded to shift down. So what we want to do is send self send shifter letter and I. In Ruby, in which everything's an object, the way that you actually talk about calling a method on an object is really in terms of sending messages. You send messages to different objects. And so under the hoods, when we call shift up inside of this class, really what we're doing is we're saying, hey, object, cipher object, send cipher object the message shift down with the parameters letter and I. That's the message that we're sending it. So this is just a little bit of metaprogramming that allows us to consolidate both of those into a single method here and get rid of some of the duplication that we saw. All right, so let's see if there's anything else. So these are both pretty clean now, right? We want to process the ciphertext by shifting down, or process the ciphertext, the plain text, by shifting up. Generate key, I really don't see anything I want to change there. Process, we take our input chars, map them with index, and we shift them. I think that's okay. Random letter. Random letter is actually kind of doing two things here. We're getting an ordinal, a number, an integer representation of a letter, and converting it to the character. So I want to call this random ordinal because it's the ordinal integer of a letter. And then I'm going to put that here and delete those outer parentheses. Just breaks it up a little bit more. I don't know that, random ordinal by itself makes sense. It's the char as an integer, but I think in context, it makes sense. Okay, shift distance takes an index. I think this works. You could also do that. Take the ord of the letter A, because that's literally what you're doing. It's not really the shift distance. It's the okay, so yeah. I like this better, and the reason why, even though this is 97, in fact, we can define it up here. I think this is a better way to define it, actually. Why is it 97? Because it is the integer, the ordinal integer representing A. But in shift distance, it doesn't make sense. It only makes sense because A.ord and alphabet offset happen to both be 97 because they both represent A. But really, conceptually, the shift distance, it's not conceptually, it's not the distance between that letter from the key and the alphabet offset. No, conceptually, it's the shift distance is the distance between that letter in the key and A. Does that make sense? Why conceptually this is so? Even though A.ord is 97, which is the same value as alphabet offset for almost exactly the same reason, conceptually it's actually different. And so I want to keep those. I want to keep those separate here. Okay. So what about this? Shift up and shift down. There is a lot of duplication here. The only difference is this bit at the beginning. And so what this will give us, what this gives us is the raw number, the raw ordinal that is our new, that the raw number that represents our new, here, let me back up. Let's go this way. Everything before .chr gives us the new integer value of our new letter. All of this stuff, minus alphabet offset, modulo alphabet length, plus alphabet offset, all of that stuff applies to this here. And this bit at the beginning gives us the raw ordinal that we have to then normalize to the alphabet because it could be too big or too little. So we want to normalize that value. So I think what I'm going to do, let me split this out just so raw ordinal is that. Let me call this raw ordinal. Let me replace that. And I'm going to do the same thing here. Plus, I don't know why I'm typing this out. Because if I do this, I can, so if now you look, line 50 and line 55 are identical. So I can move that to another method that will give me a normalized ordinal that I will then convert, that I give raw ordinal to. That will then give me, that I can then convert to a CHR. So let me try to define this. Normalized ordinal takes a raw ordinal. And it doesn't do that bit. So I can call that in both of these places. And I'm going to pull the difference back here. So to shift up or down means to take our normalized ordinal, call normalized ordinal with the shifted, the raw ordinal here, which is our the ordinal integer representing our letter plus or minus the shift distance, and return a character. Return that as a character. Oh my goodness. That was a lot of work. You know what? I think I'm going to call it. This is passing. I think I'm going to call it. Okay, cool. Well, thanks for watching, and thanks for sticking through this long if you have. If you're interested in my method that I use for refactoring code, and really when I'm starting from scratch, writing code from scratch, my whole TDD process of writing code today that I won't hate in 6 months, code that's maintainable, being a hero to my team and adding massive value to my company and to my team, then you're going to want to check out my course, which is linked down in the description, Tactical Refactoring. It's a premium course that I just released, and it's a video course. Go check it out, and I hope to see you there. And either way, I will see you in the next video.